Section 2.4, Venn diagrams with three sets and verification of equality of sets. So when we have a Venn diagram with three sets, we have 8 regions as shown here. The general procedure for filling in a Venn diagram with 3 sets is you're going to start in the center with region 5 and fill in the elements or the number of items that belong to all 3 sets. Then you're going to work your way out 2 sets at a time, remembering that you've already entered a number into generally region 5. So when you look at the elements that belong to 2 sets at a time, you have to take that into consideration as you're filling in regions 2, 4, and 6. And likewise, when you go out to the large sets like set 1, you want to make sure you'll probably be given information on what belongs to set 1. Remember, you've already filled in 3 of the 4 regions that compose set A, for instance, and you want to make sure you make an adjustment for that. We're going to work some examples so you can see how this works. So let's do this one first. Let's use a Venn diagram with 3 sets to write a particular set operation in roster form, and they want us to write A intersect B in roster form. So if we look here, here's set A, and here is set B. Their intersection is going to be these 2 regions here, which are actually regions 2 and 5. And we're going to list the elements that belong to those, which is going to be 3, 11, and 14. And blood types. Human blood is classified according to the presence or absence of specific antigens A, B, and Rh in the red cells. Antigens are highly specified proteins and carbohydrates that will trigger the production of antibodies in the blood to fight infection. Blood containing the Rh antigen is labeled positive, while blood lacking the Rh antigen is labeled negative. Blood lacking both A and B antigens is type O. Sketch a Venn diagram with 3 sets, A, B, and Rh, and place each type of blood into the proper region. A person has only one type of blood. So if we look over here, these are the Rh positive bloods, and we have A positive, B positive, AB positive, and O positive. And then on the Rh negative, we have A negative, B negative, AB negative, and O negative. So we have 8 blood types, and remember in our 3-set Venn diagram, there's 8 regions. And so here's how the sets would go. So if this is set A, blood type A, this is set B for blood type B, this is the set for Rh positive, and then in the background, well, I shouldn't say in the background, but outside of each of the sets is going to be, so for instance, if this is set A, everything outside of A is going to be not A. Everything outside of set B is not B, is likewise for Rh factor. So blood containing Rh is positive and not containing Rh is negative. So all the blood in the Rh circle is positive. All the blood outside the Rh circle is negative. And if you notice in the center here, this is AB positive. Now, if you go up here, it's AB negative. Down here we have set A and positive, so it's A positive. Over here is B and Rh positive, so B positive. Then we go up here to region 1, A negative, region 3, B negative, region 7, O positive, and O negative is back here in region number 8. And you have a homework problem that's similar to this one. So, verification of equality of sets. To verify set statements are equal for any 2 sets selected, we can use deductive reasoning with Venn diagrams. If both statements represent the same regions on the Venn diagram, then the statements are equal for all sets A and B. Determine whether A intersect B, the complement of that, is the same as A complement union B complement for all sets A and B. So draw a Venn diagram with the 2 sets A and B, label the regions. Now, if we take A intersect B complement, if I go back here, A intersect B is right here, region 2, and then if I take the complement of that, I get regions 1, 3, and 4. Which is what we've listed down here. And then if we take A complement union B complement, so A complement is 3 and 4, B complement is 1 and 4, and if I take the union of those, I get 1, 3, and 4. And I notice those are identical. So this tells us that this statement is true. So the complement of the intersection of sets A and B is the same as the union of the complements of set A and B. And that is actually one of the laws we use to determine equality of statements for sets, and De Morgan's laws. And there are 2 laws. The one we just showed, which we proved, and the second one is that the complement of the union of A and B is equal to the intersection of the complements. Use the Venn diagram to determine if the statements are equal for all sets E and F. And we're going to look at E intersect F, and then E complement, union, F complement, and then take the complement of that. So we know that E intersect F is region 2. So that part's easy. Now we want to look at this part here. So E complement contains regions 3 and 4. F complement contains regions 1 and 4. And then if we take the union of those, we get regions 1, 3, and 4. And then if we take the complement of that, we get region 2. And so these are true. These two statements are equal for all sets E and F. Now I want to use De Morgan's law to show that this is true. So we can use this law. If you look at this statement right here, it's very similar to this statement here. The difference is the right statement is similar to the law, the right statement up here. Let's change A to E complement, and we're going to change B to F complement. Notice the pattern. Okay, up here we have A goes to A complement, B goes to B complement. So what's going to happen in our statement, E complement is going to go to E, F complement is going to go to F, and then finally, remember what happens, we go from a union to an intersection, we go from a union to an intersection, so we've used De Morgan's law to also show those two statements are equal. Use the symbols A, B, the union, intersection, and the complement as necessary to describe the shaded region. So we have 4 choices here. So the first question is, which regions are shaded? And we see the shaded regions are 1, 3, and 4. So let's look at option A. So the first thing we want to look at is A intersect B, and that includes region 2. And then we want to look at A union B and take the complement of that. So A union B is 1, 2, and 3. The complement of that is 4. And then we want to take the union, and so that gives me regions 2 and 4, and that's not what I want in my answer. I want 1, 3, and 4. So let's take a look at option B. A union B and take the complement. So A union B is regions 1, 2, that should say 1, 2, and 3. And the complement of that would be region 4. That's not the shaded region that we're seeing. Let's take option C. A intersect B is region 2. Take the complement of that, which will give me 1, 3, and 4. This is the shaded regions that we see, that we identified. So C appears to be the correct answer, but I'm going to go ahead and check D and just to be sure. So A complement is regions 3 and 4. B is regions 2 and 3. Take the intersection, and we get region 3. This is not the shaded region. So the correct answer here is region C.